Section 1 of the History of Chemistry. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lawrence Trask, Mount Vernon, Ohio. InterfaceAudio.com. Volume 1, Chapter 1 of Alchemy, Part 1. Chapter 1 of Alchemy. The word chemistry, chemia, first occurs in Suidas, a Greek writer, who is supposed to have lived in the 11th century, and to have written his lexicon during the reign of Alexius Comnenus. Under the word chemia in his dictionary we find the following passage. Chemistry, the preparation of silver and gold. The books on it were sought out by Diocletian and burnt, on account of the new attempts made by the Egyptians against him. He treated them with cruelty and harshness as he sought out the books written by the ancients on the chemistry of gold and silver, and burnt them. His object was to prevent the Egyptians from becoming rich by the knowledge of this art, lest, emboldened by abundance of wealth, they might be induced afterwards to resist the Romans. Under the word "deros," a skin, in the lexicon, occurs the following passage. Deros, the golden fleece which Jason and the Argonauts, after a voyage through the Black Sea to Colchis, took together with Medea, daughter of Aetes the king. But this was not what the poets represent, but a treatise written on skins, teaching how gold might be prepared by chemistry. Probably, therefore, it is called by those who lived at that time golden, on account of its great importance. From these two passages there can be no doubt that the word chemistry was known to the Greeks in the 11th century, and that it signified, at that time, the art of making gold and silver. It appears, further, that in Suidas' opinion, this art was known to the Egyptians in the time of Diocletian, that Diocletian was convinced of its reality, and that to put an end to it, he collected and burnt all the chemical writings to be found in Egypt. Nay, Suidas affirms that a book, describing the art of making gold, existed at the time of the Argonauts, and that the object of Jason and his followers was to get possession of that invaluable treatise, which the poets disguised under the term golden fleece. The first meaning, then, of chemistry was the art of making gold, and this art, in the opinion of Suidas, was understood at least as early as 1,225 years before the Christian era, for that is the period at which the Argonautic expedition is commonly fixed by chronologists. Though the lexicon of Suidas be the first printed book in which the word chemistry occurs, yet it is said to be found in much earlier tracts, which still continue in manuscript. Thus Scaliger informs us that he perused a Greek manuscript of Zosimus, the Panoplite, written in the 5th century, and deposited in the King of France's library. Olaus Borrichius mentions this manuscript, but in such terms that it is difficult to know whether he had himself read it, though he seems to insinuate as much. The title of this manuscript is said to be A Faithful Description of the Sacred and Divine Art of Making Gold and Silver, by Zosimus the Panoplite. In this treatise, Zosimus distinguishes the art by the name chemia. From a passage in this manuscript, quoted by Scaliger, and given also by Olaus Borrichius, it appears that Zosimus carries the antiquity of the art of making gold and silver much higher than Suidas has ventured to do. The following is a literal translation of this curious passage. The sacred scriptures inform us that there exists a tribe of genii who make use of women. Hermes mentions this circumstance in his Physics, and almost every writing, whether sacred or apocryphal, states the same thing. The ancient and divine scriptures inform us that the angels, captivated by women, taught them all the operations of nature. Offense being taken at this, they remained out of heaven, because they had taught mankind all manner of evil, and things which could not be advantageous to their souls. The Scriptures inform us that the giants sprang from these embraces. Chema is the first of their traditions respecting these arts. The book itself they called Chema, hence the art is called Chemia. Zosimus is not the only Greek writer on chemistry. Olaus Borrichius has given us a list of 38 treatises, which he says exist in the libraries of Rome, Venice, and Paris, and Dr. Shaw has increased this list to 89. But among these we find the names of Hermes, Isis, Horus, Democritus, Cleopatra, Porphyry, Plato, etc., names which undoubtedly have been affixed to the writings of comparatively modern and obscure authors. The style of these authors, as Borrichius informs us, is barbarous. They are chiefly the production of ecclesiastics, who lived between the 5th and 12th centuries. In these tracts, the art of which they treat is sometimes called chemistry, sometimes the chemical art, sometimes the holy art, and the philosopher's stone. It is evident from this that between the 5th century and the taking of Constantinople in the 15th century, the Greeks believed in the possibility of making gold and silver artificially, and that the art which professed to teach these processes was called by them chemistry. These opinions passed from the Greeks to the Arabians, when, under the caliphs of the family of Abbasides, they began to turn their attention to science, about the beginning of the 9th century, and when the enlightened zeal of the Fatimites in Africa and the Ommiades in Spain encouraged the cultivation of the sciences. From Spain they gradually made their way into the different Christian kingdoms of Europe. From the 11th to the 16th century, the art of making gold and silver was cultivated in Germany, Italy, France, and England, with considerable assiduity. The cultivators of it were called alchemists, a name obviously derived from the Greek word chemia, but somewhat altered by the Arabians. Many alchemistical tracts were written during that period. A considerable number of them were collected by Lazarus Zetzner and published at Strasbourg in 1602, under the title of Theatrum Chemicum, Praecipes Selectorum Octorum Tractatus de Chemia et Lapidis Philosophicae Antiquitae Veritae Jure Prestantia, et Operationibus Continens in Gradium ver Chemiae et Medicinae Chemicae Studiosarum, qui urbium und optimorium remediorium messem facere paturant, Congestum et inquator partes su volumina digestum. This book contains 105 different alchemistical tracts. In the year 1610, another collection of alchemistical tracts was published at Basel, in 3 volumes, under the title Artis Aurifae cum Chemium Vocunt Voluma Tria. It contains 47 different tracts. In the year 1702, Mangetus published at Geneva 2 very large folio volumes, under the name Bibliotheca Chemica Curiosa, su rerum ad alchemiam partinium thesaurus instructissimus, cu non tantum artis aurifae ac scriptorum and innubilurum historia traditur, lapidis veritas argumentus et experimentus innumerus imo et juris consultium judicius evincitur, termini obscurius explicantur, cautions contra impostors et difficultes in tinctura universala confidentia, auxerentes declanter, virum etiam tractatus omnes virum celebiorium, qui in magnu sudarant elixir, quique ab ipso hemerte, et diciter trismegesto ad nostra uscra tempora decrescipia scripturant cum principiis suis commentarius consino ordine dispositi exhibentur. This bibliotheca contains 122 alchemistical treatises, many of them of considerable length. 2 additional volumes of the Theatrum Chemicum were afterwards published, but these I have never had an opportunity of seeing. From these collections, which exhibit a pretty complete view of the writings of the alchemists, A tolerably accurate notion may be formed of their opinions. But before attempting to lay open the theories and notions by which the alchemists were guided, it will be proper to state the opinions which were gradually adopted respecting the origin of alchemy, and the contrivances by which these opinions were supported. Zosimus the Panoplite, in a passage quoted above, informs us that the art of making gold and silver was not a human invention, but was communicated to mankind by angels or demons. These angels, he says, fell in love with women, and were induced by their charms to abandon heaven altogether, and to take up their abode upon earth. Among other pieces of information which these spiritual beings communicated for their paramours was the sublime art of chemistry, or the fabrication of gold and silver. It is quite unnecessary to refute this extravagant opinion, obviously founded on a misunderstanding of a passage in the 6th chapter of Genesis. And it came to pass, when man began to multiply on the face of the earth, and daughters were born unto them, that the sons of God saw the daughters of men, that they were fair, and they took them wives of all which they chose. There were giants in the earth in those days, and also after that, when the sons of God came in unto the daughters of men, and they bare children to them. The same became mighty men, which were of old, men of renown. There is no mention whatever of angels or of any information on science communicated by them to mankind, nor is it necessary to say much about the opinion advanced by some, and rather countenanced by Olaus Mauritius, that the art of making gold was the invention of Tubal-Cain, whom they represent as the same as Vulcan. All the information which we have respecting Tubal-Cain is simply that he was an instructor of every artificer in brass and iron. No allusion whatever is made to gold, and that in these early ages of the world there was no occasion for making gold artificially. We have the same authority for believing, for in the 2nd chapter of Genesis, where the Garden of Eden is described, it is said, "And a river went out of Eden to water the garden, and from thence it was parted, and came into 4 heads. The name of the first is Pison. That is it which encompasseth the whole land of Havilah, where there is gold. And the gold of that land is good. There is bdellium and onyx stone." But the most generally received opinion is that alchemy originated in Egypt, and the honour of the invention has been unanimously conferred upon Hermes Trismegistus. He is by some supposed to be the same person with Chanaan, the son of Ham, whose son Mizraim first occupied and peopled Egypt. Plutarch informs us that Egypt was sometimes called Chemia. This name is supposed to be derived from Chanaan. Thence it was believed that Chanaan was the true inventor of alchemy, to which he affixed his own name. Whether the Hermes of the Greeks was the same person with Chanaan or his son Mizraim, it is impossible at this distance of time to decide. But to Hermes is assigned the invention of alchemy, or the art of making gold, by almost the unanimous consent of the adepts. Albertus Magnus informs us that Alexander the Great discovered the sepulchre of Hermes in one of his journeys, full of all treasures, not metallic, but golden, written on a table of zatadi, which others called emerald. This passage occurs in a tract of Albertus de Secretis Chemicus, which is considered as supposititious. Nothing is said of the source whence the information contained in this passage was drawn, but from the quotations produced by Craigsman, it would appear that the existence of this emerald table was alluded by Avicenna and other Arabian writers. According to them, a woman called Sarah took it from the hands of the dead body of Hermes, some ages after the flood, in a cave near Hebron. The inscription on it was in the Phoenician language. The following is a literal translation of this famous inscription from the Latin version of Kriegsmann. "I speak not fictitious things, but what is true and most certain. What is below is like that which is above, and what is above is similar to that which is below, to accomplish the miracles of one thing. And as all things were produced by the meditation of one being, so all things were produced from this one thing by adaptation. Its father is Sol, its mother Luna. The wind carried it in its belly, the earth is its nurse. It is the cause of all perfection throughout the whole world. Its power is perfect if it be changed into earth. Separate the earth from the fire, the subtile from the gross, acting prudently and with judgment. Ascend with the greatest sagacity from the earth to heaven, and then again descend to the earth, and unite together the powers of things superior and things inferior. Thus you will possess the glory of the whole world, and all obscurity will fly far away from you. This thing has more fortitude than fortitude itself, because it will overcome every subtile thing, and penetrate every solid thing. By it this world was formed. Hence proceed wonderful things, which in this wise were established. For this reason I am called Hermes Trismegistus, because I possess 3 parts of the philosophy of the whole world. What I had to say about the operation of Sol is completed. Such is a literal translation of the celebrated inscription of Hermes Trismegistus upon the emerald tablet. It is sufficiently obscure to put it in the power of commentators to affix almost any explanation to it that they choose. The 2 individuals who have devoted most time to illustrate this tablet are Kriegsmann and Gerard Dornius, whose commentaries may be seen in the first volume of Mangidus's Bibliotheca Chemica. They both agree that it refers to the universal medicine, which began to acquire celebrity about the time of Paracelsus, or a little earlier. This exposition, which appears as probable as any other, betrays the time when this celebrated inscription seems to have been really written. Had it been taken out of the hands of the dead body of Hermes by Sarah, obviously intended for the wife of Abraham, as is affirmed by Avicenna, it is not possible that Herodotus and all the writers of antiquity, both pagan and Christian, should have entirely overlooked it, or how could Avicenna have learned what was unknown to all those who lived nearest the time when the discovery was supposed to have been made? Had it been discovered in Egypt by Alexander the Great, would it have been unknown to Aristotle and to all the numerous tribe of writers whom the Alexandrian school produced? Not one of whom, however, make the least allusion to it. In short, it bears all the mark of a forgery of the 15th century, and even the tract ascribed to Albertus Magnus, in which the tablet of Hermes is mentioned, and the discovery related, is probably also a forgery, and doubtless a forgery of the same individual who fabricated the tablet itself, in order to throw a greater air of probability upon a story which he wished to palm upon the world as true. His object was in some measure accomplished, for the authenticity of the tablet was supported with much zeal by Kriegsmann, and afterward by Olaus Borrichius. There is another tract of Hermes Trismegistus entitled Tractatus Aureus de Lapidis Physici Secreto, on which no less elaborate commentaries have been written. It professes to teach the process of making the philosopher's stone, and from the allusions in it to the use of this stone as a universal medicine was probably a forgery of the same date as the emerald tablet. It would be in vain to attempt to extract anything intelligible out of this Tractatus Aureus. It may be worth while to give a single specimen, that the reader may be able to form some idea of the nature of the style. Take of moisture an ounce and a half, of meridional redness, that is the soul of the sun, a 4th part, that is half an ounce, of yellow cire, likewise half an ounce, and of aura pigmentum, a half ounce, making in all 3 ounces. Know that the vine of wise men is extracted in 3s, and its wine at last is completed in 30. End of section 1. Recording by Lawrence Trask. Mount Vernon, Ohio. InterfaceAudio.com. Section 2 of the History of Chemistry. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lawrence Trask, Mount Vernon, Ohio. InterfaceAudio.com. Volume 1, Chapter 1 of Alchemy, Part 2. Had the opinion that gold and silver could be artificially formed originated with Hermes Trismegistus, or had it prevailed among the ancient Egyptians, it would certainly have been alluded to by Herodotus, who spent so many years in Egypt, and was instructed by the priests in all the science of the Egyptians. Had chemistry been the name of a science, real or fictitious, which existed as early as the expedition of the Argonauts, and had so many treatises on it, as Suidas alleges existed in Egypt before the reign of Diocletian, it could hardly have escaped the notice of Pliny, who was so curious and so indefatigable in his researches, and who has collected, in his Natural History, a kind of digest of all the knowledge of the ancients in every department of practical science. The fact that the term chemistry never occurs in any Greek or Roman writer prior to Suidas, who wrote so late as the 11th century, seems to overturn all idea of the existence of that pretended science among the ancients, notwithstanding the elaborate attempts of Olaus Borrichius to prove the contrary. I am disposed to believe that chemistry, or alchemy, understanding by the term the art of making gold and silver, originated with the Arabians, when they began to turn their attention to medicine, after the establishment of the caliphs, or if it had previously been cultivated by the Greeks, as the writing of Zosimus the Panoplite, if genuine, would lead us to suppose, that it was taken up by the Arabians and reduced by them into regular form and order. If the works of Geber could be genuine, they leave little doubt on this point. Geber is supposed to have been a physician, and to have written in the 7th century. He admits as a first principle that metals are compounds of mercury and sulfur. He talks of the philosopher's stone, professes to give the mode of preparing it, and teaches the way of converting the different metals, known in his time, into medicines, on whose efficacy he bestows the most ample panegyrics. Thus the principles which lie at the bottom of alchemy were implicitly adopted by him. Yet I can nowhere find in him any attempt to make gold artificially. His chemistry was entirely devoted to the improvement of medicine. The subsequent pretensions of the alchemists to convert the baser metals into gold are nowhere avowed by him. I am disposed from this time to suspect that the theory of gold-making was started after Geber's time, or at least that it was after the 7th century, before any alchemist ventured to affirm that he himself was in possession of the secret, and could fabricate gold artificially at pleasure. For there is a wide distance between the opinion that gold may be made artificially, and the affirmation that we are in possession of a method by which this transmutation of the baser metals into gold can be accomplished. The first may be adopted and defended with much plausibility and perfect honesty, but the second would require a degree of skill far exceeding that of most scientific votary of chemistry at present existing. The opinion of the alchemists was that all the metals are compounds, that the baser metals contain the same constituents as gold, contaminated indeed with various impurities, but capable, when their impurities are removed or remedied, of assuming all the properties and characters of gold. The substance possessing this wonderful power they distinguish by the name of lapis philosophorum, or philosopher's stone, and they usually describe it as a red powder, having a peculiar smell. Few of the alchemists who have left writings behind them boast of being possessed of the philosopher's stone. Paracelsus indeed affirms that he was acquainted with the method of making it, and gives several processes, which, however, are not intelligible. But many affirm that they had seen the philosopher's stone, that they had portions of it in their possession, and that they had seen several of the inferior metals, especially lead and quicksilver, converted by means of it into gold. Many stories of this kind are upon record, and so well authenticated that we need not be surprised at their having been generally credited. It will be sufficient if we state one or two of those which depend on the most unexceptionable evidence. The following relation is given by Mangides on the authority of M. Gros, a clergyman of Geneva, of the most unexceptionable character, and at the same time a skillful physician and expert chemist. About the year 1650, an unknown Italian came to Geneva, and took lodgings at the sign of the Green Cross. After remaining there a day or two, he requested de Luc, the landlord, to procure him a man acquainted with Italian, to accompany him through the town, and point out those things which deserved to be examined. De Luc was acquainted with M. Gros, at that time about 20 years of age, and a student in Geneva, and, knowing his proficiency in the Italian language, requested him to accompany the stranger. To this proposition he willingly acceded, and attended the Italian everywhere for the space of a fortnight. The stranger now began to complain of want of money, which alarmed M. Gros not a little, for at that time he was very poor, and he became apprehensive, from the tenor of the stranger's conversation, that he intended to ask the loan of money from him. But instead of this, the Italian asked him if he was acquainted with any goldsmith, whose bellows and other utensils they might be permitted to use, and who would not refuse to supply them with the different articles requisite for a particular process which he wanted to perform. M. Gros named a M. Bureau, to whom the Italian immediately repaired. He readily furnished crucibles, pure tin, quicksilver, and the other things required by the Italian. The goldsmith left his workshop that the Italian might be under less restraint, leaving M. Gros with one of his own workmen as an attendant. The Italian put a quantity of tin into one crucible, and a quantity of quicksilver into another. The tin was melted in the fire, and the mercury heated. It was then poured into the melted tin, and at the same time a red powder, enclosed in wax, was projected into the amalgam. An agitation took place, and a great deal of smoke was exhaled from the crucible. But this speedily subsided, and the whole being poured out formed 6 heavy ingots, having the color of gold. The goldsmith was called in by the Italian, and requested to make a rigid examination of the smallest of these ingots. The goldsmith, not content with the touchstone and the application of aqua fortis, exposed the metal on the cupel with lead, and fused it with antimony, but it sustained no loss. He found it possessed of the ductility and specific gravity of gold, and full of admiration, he exclaimed that he had never worked before upon gold so perfectly pure. The Italian made him a present of the smallest ingot as a recompense, and then, accompanied by M. Gros, he repaired to the mint, where he received from M. Bacuet, the mint-master, a quantity of Spanish gold coin, equal in weight to the ingots which he had brought. To M. Gros he made a present of 20 pieces, on account of the attention that he had paid to him, and after paying his bill at the inn, he added 15 pieces more, to serve to entertain M. Gros and M. Bureau for some days, and in the meantime he ordered a supper, that he might on his return have the pleasure of supping with these 2 gentlemen. He went out, but never returned, leaving behind him the greatest regret and admiration. It is needless to add that M. Gros and M. Bureau continued to enjoy themselves at the inn till the 15 pieces, which the stranger had left, were exhausted. Mangides gives also the following relation, which he states upon the authority of an English bishop, who communicated it to him in the year 1685, and at the same time gave him about half an ounce of the gold which the alchemist had made. A stranger, meanly dressed, went to Mr. Boyle, and after conversing for some time about chemical processes, requested him to furnish him with antimony and some other common metallic substances, which then fortunately happened to be in Mr. Boyle's laboratory. These were put into a crucible, which was then placed in a melting furnace. As soon as these metals were fused, the stranger showed a powder to the attendants, which he projected into the crucible, and instantly went out, directing the servants to allow the crucible to remain in the furnace till the fire went out of its own accord, and promising at the same time to return in a few hours. But as he never fulfilled his promise, Boyle ordered the cover to be taken off the crucible, and found that it contained a yellow-colored metal, possessing all the properties of pure gold, and only a little lighter than the weight of the materials originally put into the crucible. The following strange story is related by Helvetius, physician to the Prince of Orange, in his Vitalis Aureus. Helvetius was a disbeliever of the philosopher's stone and the universal medicine, and even turned Sir Kenelm Digby's sympathetic powder into ridicule. On the 27th of December, 1666, a stranger called upon him, and after conversing for some time about a universal medicine, showed a yellow powder, which he affirmed to be the philosopher's stone, and at the same time 5 large plates of gold, which had been made by means of it. Helvetius earnestly entreated that he would give him a little of this powder, or at least that he would make a trial of its power, but the stranger refused, promising, however, to return in 6 weeks. He returned accordingly, and after much entreaty he gave to Helvetius a piece of the stone, not larger than the size of a rape-seed. When Helvetius expressed his doubt whether so small a portion would be sufficient to convert 4 grains of lead into gold, the adept broke off 1/2 of it, and assured him that what remained was more than sufficient for the purpose. Helvetius, during the first conference, had concealed a little of the stone below his nail. This he threw into the melted lead, but it was almost all driven off in smoke, leaving only a vitreous earth. When he mentioned the circumstance, the stranger informed him that the powder must be enclosed in wax before it be thrown into the melted lead, lest it should be injured by the smoke of the lead. The stranger promised to return the next day and show him the method of making the projection, but having failed to make his appearance, Helvetius, in the presence of his wife and son, put 6 drachms of lead into a crucible, and as soon as it was melted, he threw into it the fragment of the philosopher's stone in his possession, previously covered over with wax. The crucible was now covered with its lid, and left for 1/4 of an hour in the fire, at the end of which time he found the whole lead converted into gold. The color was at first a deep green. Being poured into a conical vessel, it assumed a blood-red color, but when cold, it acquired the true tint of gold. Being examined by a goldsmith, he considered it as pure gold. He requested Porelius, who had the charge of the Dutch mint, to try its value. 2 drachms of it being subjected to quartation and solution in aqua fortis, were found to have increased in weight by 2 scruples. This increase was doubtless owing to the silver, which still remained enveloped in the gold after the action of the aqua fortis. To endeavor to separate the silver more completely, the gold was again fused with 7 times its weight of antimony, and treated in the usual manner, but no alteration took place in the weight. It would be easy to relate many other similar narratives, but the 3 which I have given are the best authenticated that I am acquainted with. The reader will observe that they are all stated on the authority not of the persons who were the actors, but of others to whom they related them, and some of these, as the English bishop, perhaps not very familiar with chemical processes, and therefore liable to leave out or misstate some essential particulars. The evidence, therefore, though the best that can be got, is not sufficient to authenticate these wonderful stories. A little latent vanity might easily induce the narrators to suppress or alter some particulars, which, if known, would have stripped the statements of everything marvelous which they contain, and let us into the secret of the origin of the gold, which these alchemists boasted they had fabricated. Whoever will read the statements of Paracelsus respecting his knowledge of the philosopher's stone, which he applied not to the formation of gold but to medicine, or whoever will examine his formulas for making the stone, will easily satisfy himself that Paracelsus possessed no real knowledge of the subject. But to convey as precise ideas on the subject as possible, it may be worth while to state a few of the methods by which the alchemists persuaded themselves that they could convert the baser metals into gold. In the year 1694, an old gentleman called upon Mr. Wilson, at that time a chemist in London, and informed him that at last, after 40 years' search, he had met with an ample recompense for all his trouble and expenses. This he confirmed with some oaths and imprecations, but considering his great weakness and age, he looked upon himself as incapable to undergo the fatigues of the process. "I have here," says he, "a piece of sol, gold, that I made from silver about 4 years ago, and I cannot trust any man but you with so rare a secret. We will share equally the charges and profit, which will render us wealthy enough to command the world." The nature of the process being stated, Mr. Wilson thought it not unreasonable, especially as he aimed at no peculiar advantage for himself. He accordingly put it to the trial in the following manner. 12 ounces of Japan copper were beat into thin plates, and laid stratum super stratum with 3 ounces of flowers of sulphur in a crucible. It was exposed in a melting furnace to a gentle heat, till the sulphureous flames expired. When cold, the ace ustum, sulphuret of copper, was pounded and stratified again, and this process was repeated 5 times. Mr. Wilson does not inform us whether the powder was mixed with the flowers of sulphur every time it was heated, but this must have been the case. Otherwise the sulphuret would have been again converted into metallic copper, which would have melted into a mass. By this first process, then, bisulphuret of copper was formed, composed of equal weights of sulphur and copper. 2. 6 pounds of iron wire were put into a large glass body, and 12 pounds of muriatic acid poured upon it. 6 days elapsed, during which it stood in a gentle heat, before the acid was saturated with the iron. The solution was then decanted off and filtered, and 6 pounds of new muriatic acid poured on the undissolved iron. This acid, after standing a sufficient time, was decanted off and filtered. Both liquids were put into a large retort and distilled by a sand heat. Towards the end, when the drops from the retort became yellow, the receiver was changed, and the fire increased to the highest degree, in which the retort was kept between 4 and 6 hours. When all was cold, the receiver was taken off, and a quantity of flowers was found in the neck of the retort, variously colored, like the rainbow. The yellow liquor in the receiver weighed 10 ounces and a half. The flowers, chloride of iron, 2 ounces and 3 drachms. The liquid and flowers were put into a clean bottle. 3. Half a pound of sal inixum, sulphate of potash, and 1.5 pounds of nitric acid were put into a retort. When the salt had dissolved in the acid, 10 ounces of mercury, previously distilled through quicklime and salt of tartar, were added. The whole being distilled to dryness, a fine yellow mass, pernitrate of mercury, remained in the bottom of the retort. The liquor was returned with 1/2 pound of fresh nitric acid, and the distillation repeated. The distillation was repeated a 3rd time, urging this last cohobation with the highest degree of fire. When all was cold, a various-colored mass was found in the bottom of the retort. This mass was doubtless a mixture of sulphate of potash and pernitrate of mercury, with some oxide of mercury. 4. 4 ounces of fine silver were dissolved in 1 pound of aqua fortis. To the solution was added the bisulphuret of copper, 4 ounces, of the mixture of sulphate of potash, pernitrate of mercury, and oxide of mercury, 1 ounce and a half, and of the solution of perchloride of iron, 2 ounces and a half. When these had stood in a retort 24 hours, the liquor was decanted off, and 4 ounces of nitric acid were poured upon the little matter that was not dissolved. Next morning a total dissolution was obtained. The whole of this dissolution was put into a retort and distilled almost to dryness. The liquid was poured back, and the distillation repeated 3 times. The last time the retort being urged by a very strong fire, till no fumes appeared, and not a drop fell. The matter left in the bottom of the retort was now put into a crucible. All the corrosive fumes were gently evaporated, and the residue melted down with a fluxing powder. This process was expected to yield 5 ounces of pure gold, but on examination the silver was the same, except the loss of half a pennyweight, as when dissolved in the aqua fortis. There were indeed some grains among the scoria, which appeared like gold, and would not dissolve in aqua fortis. No doubt they consisted of peroxide of iron, or perhaps persulphuret of iron. Mr. Wilson's alchemistical friend, not satisfied with his first failure, insisted upon a repetition of the process, with some alteration in the method and addition of a certain quantity of gold. The whole was accordingly gone through again, but it is unnecessary to say that no gold was obtained, or at least the 2 drachms of gold employed had increased in weight by only 2 scruples and 13 grains. This addition was doubtless owing to a little silver, from which it had not been freed. End of Section 2. Recording by Lawrence Trask, Mount Vernon, Ohio. InterfaceAudio.com. Section 3 of The History of Chemistry. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lawrence Trask, InterfaceAudio.com, Mount Vernon, Ohio. The History of Chemistry by Thomas Thompson. Volume 1, Chapter 1 of Alchemy, Part 3. I shall now give a process for making the philosopher's stone, which was considered by Mangetus as of great value, and on that account was given by him in the preface to his Bibliotheca Chemica. 1. Prepare a quantity of a spirit of wine, so free from water that it is wholly combustible, and so volatile that when a drop of it is let fall it evaporates before it reaches the ground. This constitutes the first menstruum. 2. Take pure mercury, revived in the usual manner from cinnabar. Put it into a glass vessel with common salt and distilled vinegar. Agitate violently, and when the vinegar acquires a black color, pour it off and add new vinegar. Agitate again, and continue these repeated agitations and additions till the vinegar ceases to acquire a black color from the mercury. The mercury is now quite pure and very brilliant. 3. Take of this mercury 4 parts, of sublimed mercury, mercuri meteoricitae, prepared with your own hands, 8 parts. Triturate them together in a wooden mortar with a wooden pestle, till all the grains of running mercury disappear. This process is tedious and rather difficult. 4. The mixture thus prepared is to be put into an aludel, or sand bath, and exposed to a subliming heat, which is to be gradually raised till the whole sublimes. Collect the sublimed matter, put it again into the aludel, and sublime a second time. This process must be repeated 5 times. Thus a very sweet and crystallized sublimate is obtained. It constitutes the salt of wise men, sal sapientum, and possesses wonderful properties. 5. Grind it in a wooden mortar, and reduce it to powder. Put it into a glass retort, and pour upon it the spirit of wine, No. 1, till it stands about 3 finger-breadths above the powder. Seal the retort hermetically, and expose it to a very gentle heat for 74 hours, shaking it several times a day. Then distill with a gentle heat, and the spirit of wine will pass over, together with spirit of mercury. Keep this liquid in a well-stopped bottle, lest it should evaporate. More spirit of wine is to be poured upon the residual salt, and after digestion it must be distilled off as before, and this process must be repeated till the whole salt is dissolved and distilled over with the spirit of wine. You have now performed a great work. The mercury is now rendered in some measure volatile, and it will gradually become fit to receive the tincture of gold and silver. Now return thanks to God, who hitherto crowned your wonderful work with success. Nor is this great work involved in Cimmerian darkness, but clearer than the sun, though preceding writers have imposed upon us with parables, hieroglyphics, fables, and enigmas. 6. Take this mercurial spirit, which contains our magical steel in its belly, put it into a glass retort, to which a receiver must be well and carefully luted. Draw off the spirit by a very gentle heat. There will remain in the bottom of the retort the quintessence or soul of mercury. This is to be sublimed by applying a stronger heat to the retort, that it may become volatile, as all the philosophers express themselves. Si fixum solvis faciasque volere salutum, et volucrum figris faciat te vivere tutum. This is our Luna, our fountain, in which the king and queen may bathe. Prepare this precious quintessence of mercury, which is very volatile, in a well-shut vessel for further use. 8. Let us now proceed to the operation of common gold, which we shall communicate clearly and distinctly, without digression or obscurity, that from vulgar gold we may obtain our philosophical gold, just as from common mercury we obtained, by the preceding processes, philosophical mercury. In the name of God, then, take common gold, purified in the usual way by antimony, convert it into small grains, which must be washed with salt and vinegar, till it be quite pure. Take 1 part of this gold, and pour on it 3 parts of the quintessence of mercury, as philosophers reckon from 7 to 10. So we also reckon our number as philosophical, and we begin with 3 and 1. Let them be married together, like husband and wife, to produce children of their own kind, and you will see the common gold sink and plainly dissolve. Now the marriage is consummated. Now 2 things are converted into 1. Thus the philosophical sulphur is at hand, as the philosophers say. The sulphur being dissolved, the stone is at hand. Take, then, in the name of God, our philosophical vessel, in which the king and queen embrace each other as in a bedchamber, and leave it till the water is converted into earth. Then peace is concluded between the water and fire. Then the elements have no longer anything contrary to each other, because when the elements are converted into earth, they no longer oppose each other. For in earth all elements are at rest. For the philosophers say, when you shall have seen the water coagulate itself, think that your knowledge is true, and that your operations are truly philosophical. The gold is now no longer common, but ours is philosophical, on account of our processes. At first exceedingly fixed, then exceedingly volatile, and finally exceedingly fixed. Then the whole science depends upon the change of the elements. The gold at first was a metal, now it is a sulphur, capable of converting all metals into its own sulphur. Now our tincture is wholly converted into sulphur, which possesses the energy of curing all diseases. This is our universal medicine against all the most deplorable diseases of the human body. Therefore return infinite thanks to Almighty God for all the good things which He has bestowed upon us. 9. In this great work of ours 2 modes of fermenting and projecting are wanting, without which the uninitiated will not easily follow our process. The mode of fermenting is as follows. Take of our sulphur above described 1 part, and project upon it 3 parts of very pure gold fused in a furnace. In a moment you will see the gold, by the force of the sulphur, converted into a red sulphur of an inferior quality to the first sulphur. Take 1 part of this, and project upon it 3 parts of fused gold. The whole will be again converted into a sulphur or a friable mass. Mixing 1 part of this with 3 parts of gold, you will have a malleable and extensible metal. If you find it so, well. If not, add other sulphur, and it will again pass into sulphur. Now the sulphur will be sufficiently fermented, or our medicine will be brought into a metallic nature. 10. The mode of projecting is this. Take of the fermented sulphur 1 part, and project upon it 10 parts of mercury, heated in a crucible, and you will have a perfect metal. If its color is not sufficiently deep, fuse it again, and add more fermented sulphur, and thus it will acquire color. If it becomes frangible, add a sufficient quantity of mercury, and it will be perfect. Thus, friend, you have a description of the universal medicine, not only for curing diseases and prolonging life, but also for transmuting all metals into gold. Give therefore thanks to Almighty God, who, taking pity on human calamities, has at last revealed this inestimable treasure, and made it known for the common benefit of all. Such is the formula, slightly abridged, of Carolus Musitanus, by which the philosopher's stone, according to him, may be formed. Compared with the formulas of most of the alchemists, it is sufficiently plain. What the sublimed mercury is does not appear. From the process described, we should be apt to consider it as corrosive sublimate. On that supposition, the sal sapientum formed in number 5 would be calomel. The only objection to this supposition is the process described in number 5, for calomel is not soluble in alcohol. The philosopher's stone, prepared by this elaborate process, could hardly have been anything else than an amalgam of gold. It could not have contained chloride of gold, because such a preparation, instead of acting medicinally, would have proved a most virulent poison. There is no doubt that an amalgam of gold, if projected into melted lead or tin, and afterwards cupellated, would leave a portion of gold, all the gold, of course, that existed previously in the amalgam. It might therefore have been employed by impostors to persuade the ignorant that it was really the philosopher's stone, but the alchemist who prepared the amalgam could not be ignorant that it contained gold. There is another process given in the same preface of a very different nature, but too long to be transcribed here, and the nature of the process is not sufficiently intelligible to render an account of it of much consequence. The preceding observations will give the reader some notion of the nature of the pursuits which occupied the alchemists. Their sole object was the preparation of a substance to which they gave the name of the philosopher's stone, which possessed the double property of converting the baser metals into gold, and of curing all diseases, and of preserving human life to an indefinite extent. The experiments of Wilson and the formula of Musitanus, which have just been inserted, will give the reader some notion of the way in which they attempted to manufacture this most precious substance. Being quite ignorant of the properties of bodies and of their action upon each other, their processes were guided by no scientific analogies, and one part of the labor not unfrequently counteracted another. It would be a waste of time, therefore, to attempt to analyze their numerous processes, even though such an attempt could be attended with success. But in most cases, from the unintelligible terms in which their books are written, it is impossible to divine the nature of the processes by which they endeavored to manufacture the philosopher's stone, or the nature of the substances which they obtained. In consequence of the universality of the opinion that gold could be made by art, there was a set of impostors who went about pretending that they were in possession of the philosopher's stone, and offering to communicate the secret of making it for a suitable reward. Nothing is more astonishing than that persons could be found credulous enough to be the dupes of such impostors. The very circumstance of their claiming a reward was a sufficient proof that they were ignorant of the secret which they pretended to reveal. For what motive could a man have for asking a reward who was in possession of a method of creating gold at pleasure? To such a person money could be no object, as he could procure it in any quantity. Yet, strange as it may appear, they met with abundance of dupes credulous enough to believe their asseverations, and to supply them with money to enable them to perform the wished-for processes. The object of these impostors was either to pocket the money thus furnished, or they made use of it to purchase various substances from which they extracted oils, acids, or similar products, which they were enabled to sell at a profit. To keep the dupes, who thus supplied them with the means of carrying on these processes in good spirits, it was necessary to show them occasionally small quantities of the baser metals converted into gold. Thus they performed in various ways. Monsieur Geoffroy, Sr., who had an opportunity of witnessing many of their performances, has given us an account of a number of their tricks. It may be worth while to state a few by way of specimen. Sometimes they made use of crucibles with a false bottom. At the real bottom they put a quantity of oxide of gold or silver. This was covered with a portion of powdered crucible, glued together by a little gummed water or a little wax. The materials being put into this crucible and heat applied, the false bottom disappears, The oxide of gold or silver is reduced, and at the end of the process is found at the bottom of the crucible, and considered as the product of the operation. Sometimes they make a hole in a piece of charcoal and fill it with oxide of gold or silver, and stop up the mouth with a little wax, or they soak the charcoal in solutions of these metals, or they stir the mixtures in the crucible with hollow rods containing oxide of gold or silver within, and the bottom shut with wax. By these means the gold or silver wanted is introduced during the process, and considered as a product of the operation. Sometimes they have a solution of silver in nitric acid, or of gold in aqua regia, or an amalgam of gold or silver, which, being adroitly introduced, furnishes the requisite quantity of metal. A common exhibition was to dip nails into a liquid, and take them out half converted into gold. The nails consisted of 1/2 gold, neatly soldered to the iron, and covered with something to conceal the color, which the liquid removed. Sometimes they had metals 1/2 gold and the other half silver soldered together, and the gold side whitened with mercury. The gold half was dipped into a transmuting liquid, and then the metal heated, the mercury was dissipated, and the gold half of the metal appeared. End of section 3, recorded by Lawrence Trask, Mount Vernon, Ohio, interfaceaudio.com. Section number 4 of The History of Chemistry. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lawrence Trask, Mount Vernon, Ohio. The History of Chemistry by Thomas Thompson. Volume 1, Chapter 1 of Alchemy, Part 4. As the alchemists were assiduous workmen, as they mixed all the metals, salts, etc., with which they were acquainted, in various ways with each other, and subjected such mixtures to the action of heat in close vessels, their labors were occasionally repaid by the discovery of new substances, possessed of much greater activity than any with which they were previously acquainted. In this way they were led to the discovery of sulphuric, nitric, and muriatic acids. These, when known, were made to act upon the metals. Solutions of the metals were obtained, and this gradually led to the knowledge of various metalline salts and preparations, which were introduced with considerable advantage into medicine. Thus the alchemists, by their absurd pursuits, gradually formed a collection of facts, which led ultimately to the establishment of scientific chemistry. On this account it will be proper to notice in this place such of them as appeared in Europe during the darker ages, and acquired the highest reputation, either on account of their skill as physicians, or their celebrity as chemists. 1. The first alchemist who deserves notice is Albertus Magnus, or Albert Groot, a German, who was born, it is supposed, in the year 1193, at Bullstedt, and died in the year 1282. When very young, he is said to have been so remarkable for his dullness that he became the jest of his acquaintances. He studied the sciences at Padua, and afterwards taught at Cologne, and finally in Paris. He traveled through all Germany as provincial of the order of Dominican monks, visited Rome, and was made Bishop of Ratisbon. But his passion for science induced him to give up his bishopric, and return to a cloister at Cologne, where he continued till his death. Albertus was acquainted with all the sciences cultivated in his time. He was at once a theologian, a physician, and a man of the world. He was an astronomer and an alchemist, and even dipped into magic and necromancy. His works are very voluminous. They were collected by Petre Jamy, and published at Leyden in 21 folio volumes in 1651. His principal alchemistical tracts are the following: 1. De Rebus Metallicis et Mineralibus. 2. De Alchemia. 3. Secretorum Tractatus. 4. Breve Compendium de Ortu Metallorum. 5. Concordantia Philosophorum de Lapide. 6. Compositum de Compositus. 7. Liber Octo Capitum de Philosophorum Lapide. Most of these tracts have been inserted in the Theatrum Chemicum. They are in general plain and intelligible. In his treatise De Alchemia, for example, he gives distinct account of all the chemical substances known in his time, and of the manner of obtaining them. He mentions also the apparatus then employed by chemists and the various processes by which they had occasion to perform. I may notice the most remarkable facts and opinions which I have observed in turning over these treatises. He was of the opinion that all metals are composed of sulphur and mercury, and endeavored to account for the diversity of metals partly by the difference in the purity, and partly by the difference in the proportions of the sulphur and mercury of which they are composed. He thought that water existed also as a constituent of all metals. He was acquainted with the water bath, employed alembics for distillation, and aludels for sublimation. And he was in the habit of employing various lutes, the composition of which he describes. He mentions alum and caustic alkali, and seems to have known the alkaline basis of cream of tartar. He knew the method of purifying the precious metals by means of lead and of gold, by cementation, and likewise the method of trying the purity of gold, and of distinguishing pure from impure gold. He mentions red lead, metallic arsenic, and liver of sulphur. He was acquainted with green vitriol and iron pyrites. He knew that arsenic renders copper white, and that sulphur attacks all the metals except gold. It is said by some that he was acquainted with gunpowder, but nothing indicating such knowledge occurs in any of his writings that I have had an opportunity of perusing. 2. Albertus is said to have had for a pupil, while he taught in Paris, the celebrated Thomas Aquinas, a Dominican who studied at Bologna, Rome, and Naples, and distinguished himself still more in divinity and scholastic philosophy than in alchemy. He wrote 1. Thesaurus Alchemy Secretitium, 2. Secreta Alchemia Magnalia, 3. De Esse et Essentia Mineralium, and perhaps some other works which I have not seen. These works, so far as I have perused them, are exceedingly obscure, and in various places unintelligible. Some of the terms still employed by modern chemists occur, for the first time, in the writings of Thomas Aquinas. Thus the term amalgam, still employed to denote a compound of mercury with another metal, occurs in them, and I have not observed it in any earlier author. 3. Soon after Albertus Magnus flourished Roger Bacon, by far the most illustrious, the best informed, and the most philosophical of all the alchemists. He was born in 1214, in the county of Somerset. After studying in Oxford, and afterward in Paris, he became a Cordelier friar, and devoting himself to philosophical investigations. His discoveries, notwithstanding the pains which he took to conceal them, made such a noise that he was accused of magic, and his brethren, in consequence, threw him into prison. He died, it is said, in the year 1284, though Sprengel fixes the year of his death to be 1285. His writings display a degree of knowledge and extent of thought scarcely credible, if we consider the time when he wrote, the darkest period of the Dark Ages. In his small treatise De Mirabili Protestae Artis et Naturae, he begins by pointing out the absurdity of believing in magic, necromancy, charms, or any of those similar opinions which were at that time universally prevalent. He points out the various ways in which mankind are deceived by jugglers, ventriloquists, and etc., mentions the advantages which physicians may derive from acting on the imaginations of their patients by means of charms, amulets, and infallible remedies. He affirms that many of those things which are considered as supernatural are merely so because mankind in general are unacquainted with natural philosophy. To illustrate this, he mentions a great number of natural phenomena, which had been reckoned miraculous, and concludes with several secrets of his own, which he affirms to be still more extraordinary imitations of some of the most singular processes of nature. These he delivers in the enigmatical style of the times, induced, as he tells us, partly by the conduct of other philosophers, partly by the propriety of the thing, and partly by the danger of speaking too plainly. From an attentive perusal of his works, many of which have been printed, it will be seen that Bacon was a great linguist, being familiar with Latin, Greek, Hebrew, and Arabic, and that he had perused the most important books at the time existing in all these languages. He was also a grammarian. He was well versed in the theory and practice of perspective. He understood the use of convex and concave glasses, and the art of making them. The camera obscura, burning glasses, and the powers of the telescope were known to him. He was well versed in geography and astronomy. He knew the great error in the Julian calendar, assigned the cause, and proposed the remedy. He understood chronology well. He was a skillful physician, and an able mathematician, logician, metaphysician, and theologist. But it is as a chemist that he claims our attention here. The following is a list of his chemical writings, as given by Gmelin, the whole of which I have never had an opportunity of seeing. 1. Speculum Alchemy. 2. Epistola de secretis operibus artis de naturae et de notiliate magiae. 3. De mirabili protestate artis et naturae. 4. Medulla alchemi. 5. De arte chemiae. 6. Breviarium alchemiae. 7. Documentae alchemiae. 8. De alchemisterium artibus. 9. De secretis. 10. De rebus metallicis. 11. De sculpturis lapidum. 12. De philosophorum lapide. 13. Opus majus, or Alchemia major. 14. Breviarium de dono Dei. 15. Verbum abbreviatum de Leone Veridi. 16. Secretum Secretorum. 17. Tractatus Trium Verborum. 18. Speculum Secretorum. A number of these were collected together, and published at Frankfurt in 1603, under the title of Rogeri Baconis Angli de Arte Chemiae Scripta, in a small 12mo volume. The Opus Majus was published in London in 1733 by Dr. Jebb in a folio volume. Several of his tracts still continue in manuscript in the Harleian and Bodleian libraries at Oxford. He considered the metals as compound of mercury and sulphur. Gmelin affirms that he was aware of the peculiar nature of manganese, and that he was acquainted with bismuth. But after perusing the whole of the Speculum Alchemiae, the 3rd chapter of which he quotes as containing the facts on which he founds his opinion, I cannot find any certain allusion either to manganese or bismuth. The term magnesia indeed occurs, but nothing is said respecting its nature, and long after the time of Paracelsus, bismuth, bismatum, was considered as an impure kind of lead. That he was acquainted with the composition and properties of gunpowder admits of no doubt. In the 6th chapter of his epistle, De Secretis Operibus Artis de Naturae et de Nullitate Magiae, the following passage occurs: For sounds like thunder, and coruscations like lightning, may be made in the air, and they may be rendered even more horrible than those of nature herself. A small quantity of matter, properly manufactured, not larger than the human thumb, may be made to produce a horrible noise and coruscation. And this may be done many ways, by which a city or an army may be destroyed, as was the case when Gideon and his men broke their pitchers and exhibited their lamps. Fire issuing out of them with inestimable noise destroyed an infinite number of the army of the Midianites. And in the 11th chapter of the same epistle occurs the following passage: Mix together saltpeter, luro vopo ver con utriet, and sulphur, and you will make thunder and lightning, if you know the method of mixing them. Here all the ingredients of gunpowder are mentioned except charcoal, which is doubtless concealed under the barbarous terms luru vopo vir con utriet. But though Bacon was acquainted with gunpowder, we have no evidence that he was the inventor. How far the celebrated Greek fire, concerning which so much has been written, was connected with gunpowder, it is impossible to say, But there is good evidence to prove that gunpowder was known and used in China before the commencement of the Christian era, and Lord Bacon is of opinion that the thunder and lightning and magic stated by the Macedonians to have been exhibited in Oxydrakes, when it was besieged by Alexander the Great, was nothing else than gunpowder. Now, as there is pretty good evidence that the use of gunpowder had been introduced into Spain by the Moors, at least as early as the year 1343, and as Roger Bacon was acquainted with Arabic, it is by no means unlikely that he might have become acquainted with the mode of making the composition, and with its most remarkable properties, by perusing some Arabian writer, with whom we are at present unacquainted. Barbour, in his Life of Bruce, informs us that guns were first employed by the English at the Battle of Werewater, which was fought in 1327, about 40 years after the death of Bacon. Two novelties that day they saw, that forth in Scotland had been the name, timbers for helms was the ain, that they thought then of great beauty, and also wonder for to see. The other crackies were of war, that they before heard never ere. In another part of the same book we have the phrase guineas for crackies, showing that the term crackies was used to denote a gun or musket of some form or other. It is curious that the English would seem to have been the first European nation that employed gunpowder in war. They used it in the Battle of Crécy, fought in 1346, when it was unknown to the French, and it is supposed to have contributed materially to the brilliant victory which was obtained. 4. Raymond Lully is said to have been a scholar and a friend of Roger Bacon. He was a most voluminous writer, and acquired as high a reputation as any of the alchemists. According to Mutius, he was born in Majorca in the year 1235. His father was seneschal to King James I of Aragon. In his younger days he went into the army, but afterwards held a situation in the court of his sovereign. Devoting himself to science, he soon acquired a competent knowledge of Latin and Arabic. After studying in Paris, he got the degree of doctor conferred upon him. He entered into the order of the Minorites, and induced King James to establish a cloister of that order in Minorca. He afterwards traveled through Italy, Germany, England, Portugal, Cyprus, Armenia, and Palestine. He is said by Mutius to have died in the year 1315, and to have been buried in Majorca. The following epitaph is given by Olaus Borrichius, as engraven on his tomb. Raymundus Lulli, iugis pia dogmata nulli, sunt odiosa vira, jacet hic immormor miro, hic et sisi compi corspit sine sensibus esse. MCC in these lines denote 1300, and P, which is the 15th letter of the alphabet, denotes 15, so that if this epithet be genuine, it follows that his death took place in the year 1315. It seems scarcely necessary to notice the story that Raymond Lully made a present to Edward, King of England, of 6 millions of pieces of gold, to enable him to make war on the Saracens, which sum that monarch employed, contrary to the intentions of the donor, in his French wars. This story cannot apply to Edward III, because in 1315, at the time of Raymond's death, that monarch was only 3 years of age. It can scarcely apply to Edward II, who ascended the throne in 1305, but who had no opportunity of making war, either on the Saracens or French, being totally occupied in opposing the intrigues of his queen and rebellious subjects, to whom he ultimately fell a sacrifice. Edward I made war, both upon the Saracens and the French, and lived during the time of Raymond, but his wars with the Saracens were finished before he ascended the throne, and during the whole of his reign he was too much occupied with his projected conquest of Scotland to pay much serious attention to any French war whatever. The story, therefore, cannot apply to any of the 3 Edwards, and cannot be true. Raymond Lully is said to have been stoned to death in Africa for preaching Christianity in the year 1315. Others will have it that he was alive in England in the year 1332, at which time his age would have been 97. End of section 4. Recording by Lawrence Trask, Mount Vernon, Ohio. InterfaceAudio.com. Section number 5 of The History of Chemistry. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lawrence Trask, Mount Vernon, Ohio. The History of Chemistry by Thomas Thompson. Volume 1, Chapter 1 of Alchemy, Part 5. The following table exhibits a list of his numerous writings, most of which are to be found in the Theatrum Chemicum, the Artis Auriferae, or the Bibliotheca Chemica. 1. Praxis Universalis Magni Operis. 2. Clavicula. 3. Theoria et Practica. 4. Compendium Animae Transmutationis Artis Metallorum. 5. Ultimum Testamentum. Of this work, which professes to give the whole doctrine of alchemy, there is an English translation. 6. Elucidatio Testamentae. 7. Protestus Divitorium cum Expositione Testamentae Hermetis. 8. Compendium Artis Magici, quoad Compositium Lapidis. 9. De Lapide et Oleo Philosophorum. 10. Modus Accipiendae Aurum Potabile. 11. Compendium Alchemiae de Naturalias Philosophae. 12. Lapidarium. 13. Lux Mercuriorium. 14. Experimentae. 15. Ars Compendiosa vel Vadimicium. 16. De Accurtoriatone Lapidis. Several other tracts besides these are named by Gmelin, but I have never seen any of them. I have attempted several times to read over the works of Raymond Lully, particularly his Last Will and Testament, which is considered the most important of them all. But they are all so obscure and filled with such unintelligible jargon that I have found it impossible to understand them. In this respect they form a wonderful contrast with the works of Albertus Magnus and Roger Bacon, which are comparatively plain and intelligible. For an account, therefore, of the chemical substances with which he was acquainted, I am obliged to depend on Gmelin, though I put no great confidence in his accuracy. Like his predecessors, he was of the opinion that all the metals are compounds of sulfur and mercury, but he seems first to have introduced those hieroglyphical figures or symbols which appear in such profusion in the English translation of his Last Will and Testament, and which he doubtless intended to illustrate his positions. Though what other purpose they could serve than to induce the reader to consider his statements as allegorical, it is not easy to conjecture. Perhaps they may have been designed to impose upon his contemporaries by an air of something very profound and inexplicable. For that he possessed a good deal of charlatanry is pretty evident from the slightest glance at his performances. He was acquainted with cream of tartar, which he distilled. The residue he burnt, and observed that the alkali extracted deliquesced when exposed to the air. He was acquainted with nitric acid, which he obtained by distilling a mixture of saltpetre and green vitriol. He mentioned its powers of dissolving not merely mercury, but likewise other metals. He could form aqua regia by adding sal ammoniac or common salt to nitric acid, and he was aware of the property which it had of dissolving gold. Spirit of wine was well known to him, and distinguished by him by the names of aquae vitae ardens and argentum vivum vegetabile. He knew the method of rendering it stronger by an admixture of dry carbonate of potash, and of preparing vegetable tinctures by means of it. He mentions alum from Rocca, marcasite, white and red mercurial precipitate. He knew the volatile alkali and its coagulations by means of alcohol. He was acquainted with cupellated silver, and first obtained rosemary oil by distilling the plant with water. He employed a mixture of flour and white of egg spread upon a linen cloth to cement cracked glass vessels, and used other lutes for similar purposes. 5. Arnoldus de Villanova is said to have been born at Villeneuve, a village of Provence, about the year 1240. Olaus Borrichius assures us that in his time his posterity lived in the neighborhood of Avignon, that he was acquainted with them, and that they were by no means destitute of chemical knowledge. He is said to have been educated at Barcelona, under John Casamila, a celebrated professor of medicine. This place he was obliged to leave in consequence of foretelling the death of Peter of Aragon. He went to Paris, and likewise traveled through Italy. He afterwards taught publicly in the University of Montpellier. His reputation as a physician became so great that his attendance was solicited in dangerous cases by several kings, and even the Pope himself. He was skilled in all the sciences of his time, and was besides a proficient in Greek, Hebrew, and Arabic. When at Paris he studied astrology, and calculating the age of the world, he found that it was to terminate in the year 1335. The theologians of Paris claimed against this and several other of his opinions, and condemned our astrologer as a heretic. This obliged him to leave France, but the Pope protected him. He died in the year 1313, on his way to visit Pope Clement V, who lay sick at Avignon. The following table exists a pretty full list of his works. 1. Antidotorium. 2. Divini. 3. De Aquis Laxativus. 4. Rosarius Philosophorum. 5. Lumen Novum. 6. De Sigillis. 7. Flos Florum. 8. Epistolae Super Alchemia ad Regem Neapolitanum. 9. Liber Perfectionis Magisteri. 10. Secusa Carmina. 11. Questions de Arte Transmutationis Metallorum. 12. Testamentum. 13. Lumen Luminum. 14. Practica. 15. Speculum Alchemiae. 16. Carmen. 17. Questions ad Bonifacium. 18. Semita Semitiae. 19. De Lapida Philosophorum. 20. De Sanguine Humano. 21. De Spiritus Vini, Vino Artemoni, et Gemorem Viribus. Perhaps the most curious of all these works is the Rosarium, which is intended as a complete compend of all the alchemy of his time. The first part of it on the theory of the art is plain enough, but the second part on the practice, which is subdivided into 32 chapters, and which professes to teach the art of making the philosopher's stone, is in many places quite unintelligible to me. He considered, like many of his predecessors, mercury as a constituent of metals, and he professed a knowledge of the philosopher's stone, which he could increase at pleasure. Gold and gold water was, in his opinion, one of the most precious of medicines. He employed mercury in medicine. He seems to designate bismuth under the name marcasite. He was in the habit of preparing oil of turpentine, oil of rosemary, and spirit of rosemary, which afterwards became famous under the name Hungary water. These distillations were made in a glazed earthen vessel, with a glass top and helm. His works were published at Venice in a single folio volume in the year 1505. There were 7 subsequent editions, the last of which appeared at Strasbourg in 1613. 6. John Isaac Hollandus and his countryman of the same name were either 2 brothers or a father and son, it is uncertain which. For very few circumstances respecting these 2 laborious and meritorious men have been handed down to posterity. They were born in the village of Stolk in Holland, it is supposed in the 13th century. They were certainly after Arnoldus de Villanova, because they refer to him in their writings. They wrote many treatises on chemistry, remarkable considering the time when they wrote, for clearness and precision, describing their processes with accuracy, and even giving figures of the instruments which they employed. This makes their books intelligible, and they deserve attention because they show that various processes, generally supposed of a more modern date, were known to them. Their treatises are written partly in Latin and partly in German. The following list contains the names of most of them. 1. Opera vegetabilia ad ejus alia opera intelligenda necessaria. 2. Opera mineralia su de lapide philosophico libro duo. 3. Tractat vom Stein der Weisen. 4. Fragmenta quaedam chemica. 5. De triplis ordine elixiris e lapidis theoria. 6. Tractatus de salivus et oleis metallorum. 7. Fragmentum de opera philosophorum. 8. Rearies chemiae operations. 9. Opus Saturni. 10. De spirito uranii. 11. Hand der Philosopher. Olaus Borrichius complains that their opera mineralia abound with processes, but that they are ambiguous, and such that nothing certain can be deduced from them even after much labor. Hence they draw on the unwary tyro from labor to labor. I am disposed myself to draw a different conclusion from what I have read of that elaborate work. It is true that the processes which profess to make the philosopher's stone are fallacious, and do not lead to the manufacture of gold, as the author intended and expected. But it is a great deal when alchemistical processes are delivered in such intelligible language that you know the substances employed. This enables us easily to see the results in almost every case, and to know the new compounds which were formed during a vain search for the philosopher's stone. Had the other alchemists written as plainly, the absurdity of their researches would have been sooner discovered, and thus a useless or pernicious investigation would have sooner terminated. 7. Basil Valentine is said to have been born about the year 1394, and is perhaps the most celebrated of all the alchemists, if we except Paracelsus. He was a Benedictine monk at Erfurt in Saxony. If we believe Olaus Borrichius, his writings were enclosed in the wall of a church at Erfurt, and were discovered long after his death, in consequence of the wall having been driven down by a thunderbolt. But this story is not well authenticated, and is utterly improbable. Much of his time seems to have been taken up in the preparation of chemical medicines. It was he that first introduced antimony into medicine, and it is said that on no good authority that he first tried the effects of antimonial medicines upon the monks of his convent, upon whom it acted with such violence that he was induced to distinguish the mineral from which these medicines had been extracted by the name of antimoine, hostile to monks. What shows the improbability of this story is that the works of Basil Valentine, and in particular his Cursus Triumphalis Antimoniae, were written in the German language. Now, the German name for antimony is not antimoine, but spiceglass. The Cursus Triumphalis Antimony was translated into Latin by Kirkingius, who published it with an excellent commentary at Amsterdam in 1671. Basil Valentine writes with almost as much virulence against the physicians of his time as Paracelsus himself did afterwards. As no particulars of his life have been handed down to posterity, I shall satisfy myself with giving a catalogue of his writings, and then pointing out the most striking chemical substances with which he was acquainted. The books which have appeared under the name of Basil Valentine are very numerous, but how many of them were really written by him, and how many are suppositions, is extremely doubtful. The following are the principal. 1. Philosophia Occulta. 2. Tractat von Naturlichen and Übernatürlichen Dingen, auch von der ersten Tinctur, Ursel and Geist der Metallen. 3. Von der großen Stein der Urhelaten, Verträchtelin vom Stein der Weisen. 5. Kurzer Anhang und Klarrepetition oder Wiederlein vom großen Stein der Urhelaten. 6. De prima materia lapidis philosophici. 7. As of philosophorum se aureli occulte de materia lapidis philosophorum. 8. Apocalypsis chemica. 9. Claves 12 Philosophiae. 10. Practicae. 11. Opus proclarum ad atrumque, quod protestamante dedit filio sua abdapivo. 12. Listis testament. 13. De microcosmo. 14. Von der grossen Heimlich der Welt and ihrer Arsni. 15. Von der Wissenschaft der sieben Planeten. 16. Offenbarung der Verborgenheitsgriffe. 17. Conclusions or Schurschleden. 18. Dialogues Frietis Alberti cum Spiritu. 19. Des Sulfito el Fermento Philosophum. 20. Haliographia. 21. Triumph wagen Antimony. 22. Einiger Regser Weitlebt. 23. Licht der Natur. The only one of these works that I have read with care is Kierkegaard's translation and commentary on the Currus Triumphalis Antimoni. It is an excellent book, written with clearness and precision, and contains everything respecting antimony that was known before the commencement of the 19th century. How much of this is owing to Kierkegaard I cannot say, as I have never had an opportunity of seeing a copy of the original German work of Basil Valentine. Basil Valentine, like Isaac Hollandus, was of opinion that the metals are compounds of salt, sulfur, and mercury. The philosopher's stone was composed of the same ingredients. He affirmed that there exists a great similarity between the mode of purifying gold and curing the diseases of men, and that antimony answers best for both. He was acquainted with arsenic, knew many of its properties, and mentions the red compound which forms with sulfur. Zinc seems to have been known to him, and he mentions bismuth, both under its own name, and under that of marcasite. He was aware that manganese was employed to render glass colorless. He mentions nitrate of mercury, alludes to corrosive sublimate, and seems to have known the red oxide of mercury. It would be needless to specify the preparations of antimony with which he was acquainted. Scarcely one was unknown to him which, even at present, exists in the European pharmacopoeia. Many of the preparations of lead were also familiar to him. He was aware that lead gives a sweet taste to vinegar. He knew sugar of lead, litharge, yellow oxide of lead, white carbonate of lead, and mentions that this last preparation was often adulterated in his time. He knew the method of making green vitriol, and the double chloride of iron and ammonia. He was aware that iron could be precipitated from its solution by potash, and that iron has the property of throwing down copper. He was aware that tin sometimes contains iron, and ascribed the brittleness of Hungarian iron to copper. He knew that oxides of copper gave a green color to glass, that Hungarian silver contained gold, that gold is precipitated from aqua regia by mercury in the state of an amalgam. He mentions fulminating gold, but the important facts contained in his works are so numerous, while we are so uncertain about the genuineness of the writings themselves, that it will scarcely be worth while to proceed further with the catalogue. Thus I have brought the history of alchemy to the time of Paracelsus, when it was doomed to undergo a new and important change. It will be better. History of true chemistry, and in the first place to endeavor to determine what chemical facts were known to the ancients, and how far the science had proceeded to develop itself before the time of Paracelsus. End of Section 5. Recording by Lawrence Trask, Mount Vernon, Ohio. InterfaceAudio.com.